For as long as we've been human, we've looked up at that red dot in the sky and wondered. But what happens after we're done wondering? What comes after the first footprints? Well, the answer is living there. And that's exactly what we're going to break down today. A real, detailed architectural plan for humanity's first permanent home on another world.
And look, this isn't just some sci-fi dream. Thomas Paine, the head of NASA, way back during the Apollo era, he put it perfectly. This is about the future of our species. It's a choice, right? We can either fight over the limited resources we have here, or we can work together to reach for something bigger out there. That idea is at the very heart of this whole mission.
So, okay, why Mars? Of all the places we could go, why there? Well, it's for the same reason we've always pushed the boundaries. Humanity just does better when we have a frontier. It sparks new ideas, it inspires us, and honestly, it forces us to solve impossible problems. We've pretty much mapped every corner of Earth. So, Mars? Mars is that next great, necessary frontier.
But it's not just some romantic notion. There are some really solid, practical reasons. Mars is by far the most Earth-like planet we can actually get to. It's got water ice, carbon, nitrogen, all the basic building blocks for life are locked up in its soil and its atmosphere. It's also a huge opportunity for science, a chance for nations to work together, and maybe, just maybe, a shot at starting a whole new branch of human civilization.
Of course, dreaming about it is one thing. The reality of it is something else entirely. Let's be clear, Mars is not a friendly place. The challenges of just staying alive there are absolutely massive, not just for our technology, but for our own minds.
I mean, just look at the raw data. The atmosphere is 100 times thinner than ours, and it's all carbon dioxide. The gravity is only about a third of what we're used to. There's no magnetic field, so you're just constantly being blasted by cosmic radiation. Oh, and the average temperature is 60 degrees below zero. That makes Antarctica look like a tropical beach. Every single one of these things is a lethal problem that architecture has to solve.
And this image right here shows the most fundamental problem. Here on Earth, our buildings are constantly being squeezed, hugged by our thick atmosphere. On Mars, any habitat is basically a balloon in a vacuum. It's constantly trying to explode outwards. So every single design choice has to start from that one basic fact. How do you hold your breath permanently?
But as tough as all those engineering problems are, the pressure, the radiation, the cold, there is a bigger, way more complicated challenge. And that is, what happens when you stick a small group of very smart, very stressed out humans in a metal box 140 million miles from everything they've ever known? Yeah, that's the human element. The soul-crushing isolation. The constant battle between being crammed together and desperately needing some time alone. How do you design a space that doesn't just keep people alive, but keeps them sane, keeps them from turning on each other? A habitat on Mars can't just be a machine for living. It has to be a home. It has to support a brand new and very fragile society.
Which brings us to the next giant hurdle, logistics. We can't ship a city from Earth. I mean, the cost is just unthinkable. Every single screw, every bolt, every kilogram costs a fortune to send. So how on earth do you build a permanent home when you can't even pack your own bricks?
Well, the answer is actually really elegant, and it's been around for thousands of years. You don't bring it with you. You use what's already there. You build with the Martian soil, what scientists call regolith. It's that layer of dust and broken rock that covers the whole planet.
And the solution, believe it or not, is found right in our own history. Look at this. On the left, you've got ancient vault construction from Nubia, here on Earth. And on the right, a concept for the Mars base. The resemblance is it's uncanny. This isn't about some futuristic sci-fi material. It's about using timeless, proven engineering in a totally new place.
And the process itself is beautifully simple and tough. First, you just scoop up the local dirt. You mix it with a bit of water, and you press it into bricks. Then, you use those bricks to build domes and vaults, shapes that are naturally super strong. A quick glaze on the inside makes the whole thing airtight. It's simple, it's effective, and it uses what you've got right there.
Now this is where the design gets really clever. It's a hybrid system. For the big, permanent, public areas, you use those heavy, strong masonry vaults that you build on site. But for the private living quarters, you use lightweight, inflatable modules that you can ship from Earth much more easily. It's really the best of both worlds. You get strength and permanence for the community spaces and lightweight efficiency for private life.
So we have our building blocks, we have our techniques, but how do you put them all together? A settlement is way more than just a collection of rooms. It needs a logic, an urban plan that lets it work, lets it grow, and helps build a healthy community.
So the design borrows another idea that's been proven here on Earth, the linear city. Just imagine a central spine, like a main hallway, that has all the critical life support and walkways. Then, as the population grows, you can just add new modules onto the spine, kind of like plugging in Legos, without messing up the core of the city. It's safe, it's efficient, and it's built to expand from day one.
And we keep coming back to this because it's so important. Just surviving is not the goal. A design can't just be about efficient plumbing and good wiring. It has to feed those deep psychological needs we talked about. It has to feel like a place that's actually worth living in. And the secret weapon for that is life itself. Plants. They aren't just there to make oxygen and food. In this design, greenery is a core part of the architecture. It's used to make spaces feel softer, to create a bit of privacy, to make natural spots for people to hang out, and to give everyone that crucial psychological connection to something that's alive. Okay, so we've looked at the why, the what, and the how. Now let's put it all together. Let's take a quick virtual tour of what this first home on Mars would actually look and feel like. First, the location is picked very carefully. It's tucked right up against the base of a mesa, using the Martian landscape itself as a natural shield and a solid foundation. The architecture doesn't try to fight the environment, it works with it. And this part is just genius. It solves so many problems at once. The habitats are buried under a few meters of that Martian dirt, which is one of the best radiation shields you can get. But, and this is the clever part, to keep it from feeling like a cave, these incredible light shafts funnel natural sunlight deep down into the living areas. So you're protected, but you're still connected to the rhythm of day and night on your new planet.
And this is the result of all that planning. Just look at the inside. It is not a cramped, sterile metal tube. Those ancient building techniques create these huge, soaring open spaces. They feel warm, solid, and most importantly, safe. It's full of light, it's full of plants. It's a real community space designed for people to actually thrive in. It's a sanctuary from that harsh red world just outside the walls.
There's a real beautiful irony to it all, isn't there? To build our high-tech future on a whole other planet, we're reaching back to some of the oldest, most basic ideas of what it means to build a home and what it means to build a community.
You know, it really speaks to something deep inside us, that impulse to just go, to see what's over the next hill. It's a huge part of what makes us human. It's all about that sense of wonder.
And that, really, leads us to the final and maybe the most important question of all, because this isn't just a challenge of engineering or architecture. It's a societal challenge. We're getting a chance to start over, to create a whole new branch of humanity. So when we finally get there and plant our feet in that red dust, what kind of society are we going to choose to build?